Good morning, everyone. Welcome again to Basic Math. Now, we want to have a quick view on this concentric circle. We want to look at the length of finding the length of the arc and finding the perimeter of a sector. We're going to see how long we can take to beat off these two things. All right, so as you see on the screen, there are some circles, or in the same breath too, before I jump to the circles. I recognize that I have not posted content in a while. I want to apologize for that. It's due to many reasons. But we'll see how we can build up from this point going into the summer so that content can keep on going with a smooth flow. All right, so back to the slides. We noticed that there are some circles there. The first one is demonstrating a full circumference with the blue line showing that that's the distance around the boundaries of the circle. Is actually the part, the circumference is actually the part that allows you to know that it's a circle. Alright, and then now, I want to apologize if you might hear some vehicle noises as we go through dogs barking for some reason. But let's go through anyhow. Yes, so we have a half of circle right there. Then we have that circle divided into four parts, so that's a quarter. Then this into three parts, so that's um, in a few thirds, three thirds, and then we have 72 degrees and 349. So let's see how it goes. So right now we have the circle there, a half a circle. How would we be able to express that length of arc as a part of the whole circumference? Well, I usually say we have to um, create a fraction, but how do we create a fraction? What function of the circle and what feature of the circle allows us to create a fraction? The feature is the fact that there is 360 degrees um, of turn in a circle. A circle is a complete revolution, which is 360. And so if we have just a part of that revolution, um, then we can create an angle. And then looking at the fact of arcs actually create um, an angle that is less than 360. And so if you make a ratio between those and the 360, you will be able to create that fraction that you need to find the length of the arc. So how do we do a semicircle? Somebody may ask. That's just a straight line. You can look at the feature. Angles formed by a straight line is 180 degrees. So right at the center there, a 180 degrees is formed. So we could express this as 180 over 360, which is the same as a half. And we can say that it is also 50%. Now, the next one that is cut into four, it's cut into quarters. Now, what is a quarter of the 360? 90. All right, so we have 90 over 360 or a quarter, 25%. Then further, we have 120. What fraction can this come up with? So 120 over 360, it's 1 over 3, or 33.3%. Then we have 72, that becomes 72 over 360, or 1/5, 20%. And then now this ugly round figure is not so nice. We can look at it 349, but if we check, we realize that the 349 is the big part, but the part that we're checking about is that little part there. So we subtract 349 from 360. We're left with 11 over 360, and that cannot be simplified any further. So that's the story. So the arc is a part of the circumference of a circle, and it comes from the Latin word bow or curve. Now, if we have a circle with a circumference of approximately 80 centimeters, how can we find the the length of the arc of that semicircle, that quarter of a circle, and that three-quarter of a circle. Well, the thought is to use the fractions that are presented, all right? There will be a little switch up in the way you might expect it, but this is it. So since that's a half of a circle, just divide the circumference by 2, and you get that. Since that's a quarter of a circle, divide the circumference by 4, and you get that. Since this is 3/4 of a circle, you divide that circumference that you already have by 4, and then you multiply it by 3, and you get um, the length of the piece of arc there. Now, how can we calculate the length of these arcs given the angle? So I would naturally say 1 over 1 over 360 times the 1 over 360 times the circumference, right? And that one is from the fact that we have 1 degree. So 1 over 360 times the 80, right? And we should get the answer, right? The PowerPoint presents it a different way because 1 times 80 is 80. So we have 80 over 360, which can be reduced to 0.22 as a decimal fraction. Then we have 6 degrees there. So again, we have what? 6 over 360 times the 80, right? Now we can switch it around and say 80 over 360 times the 6. Same thing, because in multiplication, um, we have a commutative property flowing. Multiplication is commutative. So the answer is 1.3. And then we have 40 right here. So the same thing, we're going to put 40 over 360 times 80 over 360 times the 40. Well, it can be 40 over 360 times the 80, which is the ideal one, right? And we get 8.9 centimeters, right? So the formula, general formula that I usually use for length of arc is the length of arc equal to theta over 360 times the circumference, right? Or you can do the circumference times theta over 360. Or you can do it in whichever manner you saw me do it a while ago. So the first thing is to find 1 degree and then you multiply it by the circumference. So that's why you had the 80 over 360 instead of um, the 1 over 360 and so on. So here we go. The circumference of the full circle is 2 pi, which is going to give you 62.83. Then now to find the length of the arc, you multiply it by the fraction. So you place um, this 62.83 over 360, then you multiply it by the angle. So you end up with 0.9 centimeters as the length of that arc. As we continue, we have 7 centimeters the radius, 100 degrees as the angle subtended by the arc. So we find the circumference again, 43.98, and then we multiply that by the angle. That's angle is going to be 100 over, the fraction is going to be 100 over 360, right? And we end up with 12.2 centimeters. Feel free to use your calculators if you don't want. It's a good practice to work the brain too. Right? This one again, we just work out the circumference, then we put the answer over 360 and multiply that by the angle. Or you can put the angle over 360 and multiply it by the answer. Commutative property again. That's 30 centimeters for this one. This is one that you can pause the video and try. Okay, we should be back now. So we have what, 5 centimeters and 70 degrees as the angle subtended by the arc. So we go by finding the circumference. After finding the circumference, you multiply that by the angle formed by the fraction formed by the angle and the whole 360 term. Right? And you end up with 6.1 centimeters there. Here's another one. Pause the video and try it. Okay, yes, you should get something by now. So this again, find the circumference. Place the answer over 360, which is the 43.98, and you multiply that by the 155, and you get 18.9 centimeters. Don't forget your units as you go through. Find the length of the major arc here, so that's the bigger part. So that's going to be find the circumference, multiply that by the 292 by the 292 over 360, and you get 20.4. Right now the question is changing, and the if you've mastered the concept of perimeter, the concept of perimeter, you know that perimeter is the distance along the boundaries of a shape. So the perimeter of a sector is the distance along the boundaries of a sector. So we know that if we find the length of the arc, we have a part of the perimeter. We know that the rest of the shape is bounded by two radii, right? And so let's go ahead and find the perimeter of this. So we have the full circumference is 56.548 and more numbers. And we do the same process to find the length of arc to be 10.9. And then what we do to the 10.9 is add 9 and 9. So the length of the arc, I call it L, is going to be equal to 10.9 plus 2 times the radius, right? So that's 2 times 9. That's 10.9 plus 18. But I love to say work it out on the side. So 10.9 plus 18. Right? If you don't want this to look funny, you put a point zero. Put back the 9 there. 0 plus 9 is 9. 8 plus 0 is 8. And then 1 plus 1 is 2. So the answer here for the length of the arc is 28.9. What am I writing? 28.9. And remember, we don't leave off our units. It should be centimeters. All right. All right. Here's another shape. You can pause the video and try that one. While you puzzle, just remember this formula that the perimeter of the sector is equal to the length of the arc plus 2 times the radius. If you're given a diameter, as in the case of a semicircle, you know that the perimeter is equal to L plus D, which is the diameter. All right. So let's see. Somebody must have the answer for this already. So the full circumference is 43.982 centimeters, and you multiply by put that over 360 multiply by the angle, you get 16.49, but that's just the length of arc. So we're going to add the two radii with 7 plus 7, and we should get 30.5 centimeters to one decimal place. There's another shape. You guys can pause the video and work it out. All right, so here we go. Full circumference is 75.39. So you'll find the length of the arc, that's 4.6, and then you add the two radii to it. So you end up with 28.6 centimeters. Here we go again. Um, this works the same way. You find the length of the arc and multiply to find your fraction, yeah, you find the length of the arc. Then you add 20. That's 10, which is the radius plus another 10. which is the next radius that bounds the shape. You get 76.0. And remember to put the point zero, even if it seems like a well and nice round number. All right, so that's it. Um, you can always go back and try to work out the parts that we've gone through on your own. Rewrite the questions and see if you can get them. If you have a nicer method, use it and ensure that things are understood for this. The next thing that we're going to move to is the area of a circle and the area of a sector. Right, so catch you on that in the next video, which should start, well, I'll start it shortly.